The world is heating up. Each year breaks new temperature records. Heat waves last longer and affects more people. Cooling demand is rising fast. This means more air conditioners, more electricity use, and more emissions. Yet millions still have no reliable cooling at all.
Nearly 2.8 billion people live in the hottest regions on Earth. Many work and study in semi-open environments where HVAC systems fail. On one side, there are full indoor cooling systems, while on the other side, there is nothing. This space in between represents massive untapped demand in the market.
The cooling industry competes within fixed boundaries. Companies such as Samsung and Hitachi improve compressors, add smart features and strengthen branding, but the structure stays the same. Air conditioning depends on sealed spaces, stable electricity, and refrigerant gases. It is energy intensive and costly. This creates a red ocean where everyone fights for the same customers. Meanwhile, bus stops, rural schools, markets, and semi-open spaces are left out completely.
TerraCool Hubs was built to fill that gap. Instead of improving air conditioners, we rethought cooling itself. Each TerraCool unit is made of 30 engineered terracotta cones arranged in a modular structure. Terracotta is porous. The cones use honeycomb-inspired geometry where water flows through these cones. This increases the surface area and improves the evaporation efficiency. When the warm air passes through these cones, the fan with controlled speeds comes into action. The water evaporates, the heat is absorbed, and the temperature drops.
Furthermore, water circulation is handled by a small powered pump. The system is simple and modular, where one unit cools a small space, while multiple units can scale for larger areas. There are no compressors and no refrigerants in the product, just physics and smart design working together in coherence to deliver sustainable low-energy cooling that is practical, affordable, and easy to maintain in diverse environments.
When we applied the Blue Ocean framework, the shift became clear. In Eliminate, we remove refrigerant gases, compressor-based systems, and professional installation dependency. In Reduce, we lower electricity consumption, manufacturing costs, and maintenance complexity. In Raise, we increase affordability, environmental sustainability, and accessibility in heat-vulnerable regions. And in Create, we introduce a terracotta-based modular cooling system, a low-energy commuting cooling model, and a locally manufacturable solution. The strategy canvas shows the difference clearly. Traditional systems score high on mechanical complexity and refrigerant use. TerraCool scores low there. Where affordability, sustainability, and accessibility matter, TerraCool rises sharply. Instead of competing on stronger machines, we compete on smarter infrastructure.
Moving on, our focus is on non-customers. For the first tier, we have the soon-to-be non-customers. These include households that cannot afford air conditioning installations, schools with limited budgets, small clinics in hot climates, and NGOs operating in heat-prone regions. For the second tier, we have refusing non-customers. These include environmentally conscious communities which are avoiding air conditioning. Then we have off-grid rural areas, then disaster relief zones, and refugee camps. For the third and final tier, we have unexplored non-customers. These include public outdoor spaces, bus stops, community centers, informal settlements, and developing regions with no cooling infrastructure in place. These groups are not all small. They are actually the majority of the unmet market.
For this to work, the numbers must make sense. Raw materials cost about $24.50 per unit. Manufacturing adds to another $7.50. Overheads add up to $3. That brings to a total production cost of around $35 per unit. Because clay is locally available, production can be decentralized. Fabrication and assembly can happen regionally. This reduces the logistics costs and creates a local employment. Affordable to produce and practical to scale.
Evaporative cooling works best in dry and heat-stressed regions. That is our starting market. We are currently in the design and testing phase. Pilot installations will help measure real-world temperature reduction and optimize airflow. TerraCool Hubs has been awarded a $3,000 Research and Development Social Impact Grant by Nord Anglia Education to advance the sustainable cooling innovation. TerraCool does not replace air conditioning, it complements it. It serves the space traditional systems ignore.
Cooling should not be a privilege.
It should not depend on income or complex infrastructure.
And it should not accelerate the climate crisis.
TerraCool Hubs redefines cooling as infrastructure
that is affordable and sustainable
for the communities that need it the most.